Hi class, how are you today? That's fantastic! The learning target for today is to use properties of triangles to solve for missing parts of a triangle. Now, I believe you've seen a lot of this before, so a lot of this might be a review, but we're going to use a lot of algebra in this too. So, if you're a 3, you can solve for missing parts of a triangle. If you're a 2, you can solve for missing parts of a triangle, but only when no variables are involved, so only numbers. You are a 1 if you know the properties of triangles but cannot solve for missing parts of a triangle. So you know the properties but can't do anything with them. 0, you don't know the properties of triangles. Remember, please circle at the end of the video, just circle on the scale where you think you are, just so I can see where you think you are. Let's get started.
Alright, so before we go into the video, I want to talk quickly about linear pairs. So linear pairs are two angles that make a straight line, and these angles are supplementary. So what this means is, if you have a straight line, and there happens to be an angle here, then these two angles you have, this one and this one, are known as linear pairs. So they make a straight line. And they're supplementary. So what it means to be supplementary, it means that they add to 180 degrees. We know this because they make a straight line. The two angles together make a straight line, so that means they have to add up to 180. So if we've got this angle over here is 80 degrees, then this one has to be 100 degrees. And that works anywhere there's a straight line. With this one it might look easy, but sometimes it'll show up in a triangle. So here notice we have a triangle, and we have a line sticking out of it. So if I start off by telling you that this is a 75-degree angle, then over here you can tell that this must be a 105-degree angle because it's a linear pair. They create a straight line, so they have to add up to 180 degrees. Even though this is not specifically a theorem about triangles, we're going to be using a lot in this section. Alright, so next we have triangle theorems. These are theorems specifically about triangles. So the first one is the angle sum theorem. So the sum of the measures of the angles of a triangle is 180 degrees. So what this means is, in this triangle, these three angles, x, y, and w, will add to 180 degrees. So what we can say is the measure of angle x plus the measure of angle y plus the measure of angle w is equal to 180 degrees. And this m here means measure. So measure of angle x. So that's just what the m means, is that it's the measure of. Next we have the exterior angle theorem. It says the measure of an exterior angle is equal to the measure of the other two interior angles. So let's say we have a triangle here. So all of the angles on the inside are the interior angles, and all the angles on the outside, such as this one that comes out of the triangle, is an exterior angle. So this angle right here is an exterior angle. So this is going to be equal to these two interior angles. And I'm marking them with different marks so we can mark them separately. If I had the same amount of marks, I'd be marking them as congruent, or the same. So these two interior angles will add to the exterior angle. So if this angle was 42, and say this angle was 61, then we could add up these two angles, which would be 103, and we'd automatically know that this would be the measure of that. We could also find it by finding out the measure of this angle and then subtracting it from 180, but this is a quicker way to do it. So if we add up the two interior angles that are not touching it, we will get the exterior angle. And the last theorem I'm going to talk about is the vertical angle theorem. The two non-adjacent angles created by intersecting lines are congruent. What that means is, if I have two intersecting lines here, the opposite angles, the non-adjacent angles, are congruent. So if I start with this angle here, the two angles next to it are adjacent to it. So it's the non-adjacent angle, the opposite angle, the one across from it. So those two are congruent, they're the same. If this bottom one was 40 degrees, the top one would be 40 degrees. That sort of thing. And it actually also works for the other two. So this angle is a vertical angle with this one. They're also the same. So those are also congruent. So any opposite angles made by intersecting lines are congruent.
Alright, now let's do some examples with this. So we have a triangle here, and the three angles are x plus 17, x plus 20, and x plus 23. And we need to solve for x. Well, we know if we add those three up, they'll equal 180, right? So, let's say x plus 17 plus x plus 20 plus x plus 23 equals 180. So, combine like terms. So, x plus x plus x is 3x. 17 plus 20 is 37. Plus 23 is 60. So, plus 60 equals 180. And then solve for x. Subtract 60 from both sides. Gives us 3x equals 120. Divide both sides by 3. And x equals 40. Alright, so in this problem, we're given that this exterior angle right here is 129 degrees. This angle right here is 102 degrees, and we need to find this missing measure right here. Well, first thing we want to do is find the interior angle here. So if we have this exterior angle, we know that this interior angle is just 180 degrees minus the exterior angle. So, 180 minus 129 will give us 51. So we know that this angle right here is 51 degrees. With the exterior angle theorem, it says that this interior angle plus this exterior angle will equal 180, but the triangle sum theorem says this angle plus this angle plus this angle will also add up to 180. So from that we can tell this angle plus this angle is the same as this angle right here. So we have that 51 plus 102 is 153 degrees, and that's our missing measure. Alright, one final example. So here we technically have two triangles going on. We have this triangle, which we know has 45 degrees and 15 degrees. We have this triangle as 27 degrees and the question mark that we want to know. And these two are unmarked. So first step, we know two angles here, so let's find the third angle of this triangle. So it's going to be 180 minus these two added up. So that'll give us 180 minus 45 plus 15 is 60. So that's 120 degrees. So this angle right here is 120 degrees. We also know that this line right here is intersecting this line right here, meaning this angle and this angle are vertical angles. And if they're vertical angles, that means these two angles are congruent. So this angle over here is also 120 degrees. So then we can just look and say, this is 27, this is 120, so this must be 180 minus these two. So 180 minus 147, which is 120 plus 127, will give us 33. So our question mark is 33 degrees. Next we're going to talk about properties of equilateral triangles. First property is all sides of a triangle are congruent if and only if all angles are congruent. First thing I want to mention is if you ever see this phrase, if and only if, it means it works both ways. So you can read it as all sides of a triangle are congruent if all angles are congruent. So if all the sides of a triangle are congruent, then that means all the angles of a triangle are congruent. But you can also read it backwards. If all the angles of a triangle are congruent, then all the sides of a triangle are congruent. So if you ever see if and only if, it works both forwards and backwards. It's a phrase that mathematicians use to show that it goes both forwards and backwards. The second property is from each angle, the angle bisector, median, and altitude are the same line. So remember those three lines that I just showed you? In an equilateral triangle, they're all the same line. So if you draw an angle bisector, it also happens to be the median and the altitude. If you draw a median, it's also the angle bisector and the altitude. If you draw an altitude, it's also the angle bisector and the median. Next, we're going to talk about properties of isosceles triangles. First property is two sides of a triangle are congruent if and only if their opposite angles are congruent. Again, here's the if and only if part. So that means it works both forwards and backwards. So two sides of a triangle are congruent if their opposite angles are congruent, or two angles of a triangle are congruent if their opposite sides are congruent. So a quick drawing of that is if these two sides are congruent, remember these little dashes through the sides mark them as congruent, then that means the angles opposite them are congruent. So we have this angle right here, so the angle opposite it is right here. And then that angle is congruent to the angle opposite this side right here, which is this one over here. So we now know that this angle is congruent to this angle. The second property, very similar to the one from equilateral triangles, is from the vertex angle, the angle bisector, median, and altitude are all the same line. So first, what is the vertex angle? Well, the vertex angle, looking up at this picture up here, is the angle that is not congruent to the others, the one that's in between the two sides that are congruent. So it's this angle right here, and I'll mark it with 2 arcs to show that it's not congruent to the other two. So that angle right there is the vertex angle. So if I were to draw an angle bisector from that angle, then it would also be a median and altitude, and so on. If I drew a median, it would be the other two, and so on. So very similar to the equilateral properties, but very specific. So the angle bisector, median, and altitude being the same line is only from the vertex angle, not the other two angles. Alright, now let's look at some examples. So in this triangle, we notice that these 3 angles, since they're marked with arcs, are all congruent to each other. So since they're all congruent, then that means all of the sides are congruent. Remember from the property of equilateral triangles, if all the angles are congruent, then all the sides are congruent. So that means this side is congruent to this side is congruent to this side. So first, let's try to solve for x. So since all these sides are equal to each other, all we have to do is set 2 of these sides equal to each other, and we can find out what x is. So let's take any 2. I'll just take 2x plus 5 and set it equal to x plus 9. And then solve for x. So subtract x from both sides, and that'll give us x plus 5 equals 9, and then subtract 5 from both sides, and that'll give us x equals 4. So we know x is 4. Now we can use that to find the measurements of all the sides. So we know that side AB is x plus 9, side AC is 2x plus 5, and side BC is 3x plus 1. So we can plug in x into all these, and we'll end up getting 4 plus 9, which is 13, and well, if all the sides are equal, we know that all of them will be 13. So we don't have to do anything more than that, and we can just say they're all 13, but just for the fun of it, I'll plug them all in. So 2 times 4 plus 5, so that'll give us 8 plus 5, which is 13, and 3x plus 1, so 3 times 4 plus 1, 3 times 4 is 12, plus 1 is 13. So all the sides are 13. Alright, let's look at another example. So it says here that triangle ABC is an isosceles triangle. So let's start off and draw a triangle. So we've got a triangle, and it's isosceles, so we'll make the marks. These 2 sides are equal. And B is the vertex angle. So that is the angle that is between the 2 sides that are equal. And then A and C. So we know that AB is 2x plus 6. BC is 4x minus 2. And AC is 3x plus 10. So the 2 sides that are equal are 2x plus 6 and 4x minus 2. So let's set them equal to each other. So we have 2x plus 6 equals 4x minus 2. Let's subtract 2x from both sides to get them together. Gives us 6 equals 2x minus 2. Add 2 to both sides will give us 8 equals 2x. Divide both sides by 2, and that'll give us x equals 4. So now that we know x is 4, plug it back into what we had. So 2x, so 2 times 4 is 8, plus 6 is 14. 4 times 4 is 16, minus 2 is 14, which it should be because we originally said that these two are equal, so they should come out to the same thing. If they don't, you probably did something wrong somewhere. And then 3x plus 10, so 3 times 4 is 12, plus 10 is 22. So those are the measurements of all of the sides. All right, one more example. So in this problem, notice here we have an isosceles triangle here. So the big triangle we see here is isosceles because it has 2 congruent sides. And we also know that it's got a line going through it that makes it so these two angles are the same. So that means it's an angle bisector. So since it cuts this angle into 2 equal pieces, it's an angle bisector. And we learned before that if it cuts the vertex angle as an angle bisector, it's also a median and it's also an altitude. So it's also a right angle here. And also these two sides are equal to each other. So if those two sides are equal to each other, because it's a median, that means we can set these two sides equal to each other. So 14 is equal to 3x plus 2. And then subtract 2 from both sides. Gives us 12 equals 3x. Divide both sides by 3. And we have x equals 4.
Alright, now time for the sponge activity. So on number 1, I want you to find x. So I give you 114 degrees here, a 38 degrees here, these two marks, you should know what those mean, and x. And use all that information to find x. So find out what the value is. Please don't just say it's right there. And number 2, find QR. So I want to know what is the measurement of QR. What's the length of QR? So you've got 4x minus 7 here, 2x plus 1 here, x plus 12 there, and these two marks here should be enough information for you to be able to find QR. Hint, you'll have to find x first before you can find out what QR is. Alright, that's it for the lesson. Once again, please make sure to take notes in the entire lesson. Take a picture of your notes and the sponge and your ranking from the beginning of the video. Submit it all to Google Classroom, and have a good night.